Lesson 7 is on rates and average and measures of central tendency, which basically includes finding the mean, median, and mode. So in the act, there were 12 clowns in each little car. If there were 132 clowns, how many little cars were there? This is from lesson 4, which was on equal groups. And so we have the number of groups, which we're not sure of, that's the number of cars, times the number in each group, or in each car, 12, equals 132. And if we're looking for a factor, then we take the product, 132, and divide that by our known factor, 12. 132 divided by 12 is 11, so there were 11 cars. Number 2 comes from lesson 5 on fractions. There were 35 trees on the property. 4/5 are deciduous. They lose their leaves in the fall and winter. How many trees on the property are deciduous? So 4/5 of 35. Of, remember, means multiply. So we have 35 total, and of those, meaning multiplied by 4/5. And when we multiply by a fraction, we multiply by the numerator. So 35 times 5, and then times 4, divided by the denominator, 5. And that gives us 28 deciduous trees. Melody weighed 7 pounds, 7 ounces at birth. How many ounces did Melody weigh? This comes from lesson 6 on unit conversions. And one thing that you'll need to know is that 1 pound is equal to 16 ounces. And that's in the table that we have in our lesson 6 guide. And so there's 2 different fractions that we could come up with that one. 1 pound over 16 ounces, or 16 ounces over 1 pound. And so we look, and they give us 7 pounds. We're going to ignore the ounces for now. We're going to add those on at the end. Right now we need to convert the pounds into ounces. So we're going to do 7 pounds over 1. I always give the information over 1. And then since I have pounds on the top in this fraction, it's going to need to be on the bottom in the next one. So I picked the one of my fractions that has pounds on the bottom. Pounds will cancel out, and this tells me since 16 and 7 are both on top, then I'm going to multiply them. So 7 times 16 is equal to 112 ounces. So that's how many ounces are in the 7 pounds that she weighed. But she was also 7 ounces more than 7 pounds. So I have to add on 7 more ounces, and I get 119 ounces. The bird flew 80 kilometers in 4 hours. What was the bird's average speed in kilometers per hour? This right here, kilometers per hour, kind of tells you what you need to do with the 2 numbers. Because if I have kilometers over hours, that's what it looks like in the symbol. So that means I have to take the number they gave me for kilometers, 80, the number they gave me for hours, 4, and divide them. 80 divided by 4 is 20 kilometers per hour. If the plane travels 400 miles per hour, how far will it travel in 5 hours? So I have 400 miles per 1 hour is what that means. And then I can see, since I have hours here, I want to cancel them out, so I just have distance, miles. They need to be on the top in the next fraction. So I have 5 hours over 1. hours cancel out, and I'm left with miles. And now I can see that 400 times 5 is how I'm going to get my answer because they're both on top. 400 times 5 gives me 2,000 miles. Number 6 says, how many pints are in a gallon of milk? Well, in your conversion, there's 2 things that you need to know. There are 4 quarts in 1 gallon, and there are 2 pints in 1 quart. So when they say that I have 1 gallon of milk, I know right away that means I have 4 quarts. So I'm going to start the conversion with that. So I'm going to have 4 quarts over 1, because 4 quarts is 1 gallon, and I have 1 gallon. And now I need to use the conversion here, and it's either going to be 2 pints over 1 quart, or 1 quart over 2 pints. Since I have quarts on the top of this fraction, I know they need to go on the bottom of this one over here. So that means I'm going to choose this fraction here, 2 quarts, or 2 pints, excuse me, over 1 quart. 2 and 4 are both in top, so I'm going to multiply them. 2 times 4 is 8. Quarts are diagonal, so they cross out, and I'm left with pints. So there are 8 pints in 1 gallon of milk. The number of points scored by the starting players on a basketball team were 8, 12, 16, 19, and 20. What is the average number of points scored per starting player? Well, to find the average, you're going to add them up. So 8 plus 12 plus 16 plus 19 plus 20. Well, 8 plus 12 is going to give me 20. 20 and 20 gives me 40. And 16 and 19 give me 35. So 40 and 35 is 75 total points. And then we're going to divide that by 5 players, 5 starting players. And 75 divided by 5 is 15. Fifteen and 15 is 30. 30 and 30 is 60. That's 4 15s, and 1 more 15 would be 75. In problems 8 through 11, it says identify the plot, write an equation, and solve the problem. In the package were 3 rows of 8 colored pencils. So the plot for this one is equal parts, or equal group, excuse me. And that's from lesson 4. The equation in general for that is the number of groups times the number in each group equals the total. Well, the number of groups is the number of rows, and there's 8 in each row, so times 8 is going to be the total. So then the solution, you just take 3 times 8 is 24 colored pencils. Number 9, Felicia scored 15 points in the first half and 33 points in all. How many points did she score in the second half? So the plot for this one is combining, because she scored some in the first half, more in the second half, and then that equaled the total. So the equation for a combining one is sum plus more equals the total. So sum is the first half, 15 points, plus more, what she scored in the second half, equals a total of 33 points. So the solution for this then, 15 plus 18 would give me 33. Another way to look at that is to solve for one of the addends. You take the sum, and subtract the known add-in. So 33 minus 15 would give you 18. There were 20 ounces of birdseed in the feeder before the birds came. When the birds left, there were 11 ounces of birdseed in the feeder. How many ounces of birdseed did the birds remove from the feeder? The plot from this one is separating. In a separating problem, you started off with some goes away, and you end up with what's left. So the equation is what you start with, in this case 20, minus what goes away, which is what we're looking for, and then what's left, in this case was 11. So our solution, 20 minus 9 would give us 11. So 9 ounces of birdseed is what they ate. President Ronald Reagan ended his second term in office in 1989. He had served 2 terms of 4 years each. What year did he begin his first term? So there's 2 parts to this. The first one is to figure out how many years he served, and that one's an equal groups plot. And the equation for that is how many groups there are. So he had 2 terms, and they were 4 years each, so that gives you the total. So the solution for this is 8. So 8 years. Okay? But we're not done. They asked what year did he begin. So now we have to use the other piece of the information, and the plot for that is going to be comparing and specifically elapsed time. And with elapsed time, you have the later time minus the earlier time equals how long it's been, the elapsed time. So the equation, it says that he ended his second term, so that's the latest time. He started sometime before 1989. So the later time is 1989 minus the earlier time, which we're not sure of what it is yet, is equal to, well, he served for 8 years total, so 8. So 1989 minus what would give me 8? Well, 1989 minus 1981 would give me 8. Write a word problem for this equation. So you could say Chucky put 9 5-pound weights on the bench press machine. How much total weight did Chucky lift? Then it says write a word problem for this equation. Well, you could say I got $14 from my grandma, but had to pay my friend back money I borrowed. I ended with $3 How much money did I owe my friend? Arrange these numbers from least to greatest. So we got some fractions and we got some ordering. So first of all, I only see one negative number, so that's going to be the least. And then 0, and then I look at the fractions. They're both less than 1. 2/3 is going to be more than the half, because half of 3 is 1.5. And 2/5 is going to be less than a half, since 2.5 would be half of 5. So I'm going to say it's 2/5 and 2/3, and then 1. Compare -11 and -10. -11 is more negative, so it is less. For each letter, write a word to describe its role. Both A and B are called addends. They're the two numbers that you add. Addends. A, B, D, E, N, D, S. Addends. When you're adding numbers, the things that you're adding are addends. And the answer is the sum. Wow, writing's not going well for me. When you multiply two numbers, the numbers being multiplied are called factors. And your answer is the product. Use the numbers 3 and 8 to provide an example of the commutative property of multiplication. So 3 times 8 equals 8 times 3. Commutative property says order doesn't matter when you're multiplying. So 3 times 8 is 24, and 8 times 3 is also 24. Use the numbers 1, 2, and 3 to provide an example of the associative property of addition. Well, associative property says that I can group numbers that are being added in any way, and it's not going to change the sum. So I can have 1 plus 2 in parentheses and then plus 3, or I could have 1 plus 2 plus 3 in parentheses. So this would be 3 plus 3, which is 6, and this would be 1 plus 5, which is also 6. So the property works. Alright, then I'm going to graph the numbers in a number line. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So -5, -2, 1, 4, and 7. When 20 is subtracted from 0, what is the result? Well, this is what that problem would read in math. 0 minus 20. Well, 0 take away 20 means that you're at -20. If 7 minus 5 equals 2, what other subtraction fact and what two addition facts are true for 7, 5, and 2? Well, you switch the place for the 5 and the 2. And then you also know that 5 plus 2 equals 7, and 2 plus 5 equals 7. If 12 divided by 4 equals 3, what other division fact and what two multiplication facts do you know? So 12 divided by, again, switch the place of the 3 and the 4. And then 4 times 3 equals 12, and 3 times 4 equals 12. True or false? Every whole number is also a counting number. Explain your answer or give a counterexample. This is false. because whole numbers include 0, but 0 is not a counting number. You always start at 1 for counting. What is the absolute value of 90? Absolute value asks how far away from 0 is negative 90. Well, it's 90 places away. What number is the opposite of 6? Opposite means opposite sign, so if it's positive 6 now, it's negative 6. And then 26. Find the value of the variable that makes the equation true and name the property illustrated. Well, if I'm going to multiply by something, that number has to be 1. So x has to be 1. And that property is called the multiplicative identity property. An identity means that you get the same number back. So in B, when we get 7 back, we know that's going to be identity. And since we're adding, it's going to be the additive identity. And the way that you get a number back by adding is you have to add 0. So that's the additive identity. All right, then we have 2020 minus 10,101. The easiest way to do this, since I'm recognizing that this number here is smaller than this number, is I'm going to do them backwards. And I do know that it's written the other way. But if I do it backwards, then I know that the sign on it is going to just be the opposite of the answer that I get. So I'll have 1, borrow to give me 10. 10 minus 2 is 8. 0 minus 0 is 0. And then 10 minus 2 is 8. So doing it the opposite way, I get positive 8,081. So then my answer must be negative 8,081, the opposite. Number 28, I would do 48 times 0.79. 9 times 8 is 72. Carry the 7. 9 times 4 is 36, plus 7 is 43. 7 times 8 is 56. 7 times 4 is 28, plus 5 is 33. Add those together, 9, 7, 3. And since I have 2 decimal places here, I gotta have 2 decimal places here. So 37, 92. And then I'll do 29 over here. If I have 60 divided by 12, how many times does 12 go into 6? It doesn't, but it goes into 60 5 times. Put the decimal place directly above. 5 times 12 is 60. I get 0, bring the 6 down. How many times does 12 go into 6? 0 times. Bring the next 0 down. How many times does 12 go into 60? 5 times. 5 times 12 is 60. So $5.05. And then the last one, reordering them. The first thing I would do is put 75 in front of 12, because I want 75 to be closer to the 4, because that's easier. And that's the commutative property that allows me to do that. Then I'm going to move the parentheses so that I do 4 times 75 first. And that's the associative property that says I can group them in any way. And then the last thing that I would do is 4 times 75. I know that 2 75s is 150, and 150 and 150 is 300. And then I'm just multiplying. 3 times 12 is 36, and then I got 2 zeros.